Guys, welcome back to my channel, Maison African Motives. Still working on O-level math for Zimsec syllabus. So we are given this question paper, which is from one of the question papers, which is actually November 2019. So this is November 2019 that we are given, and we shall just focus on this. And as you can note, guys, it's a 2-hour 30 minutes paper that you're supposed to have, and it's paper 1. So we shall just quickly rush through this paper and see what we are going to have in this case. All right, so not wasting much of your time, guys, let us quickly rush through the part of the paper and see what you're given. On the first part, you're given to express 2460 cubic centimeters. This is a cubic here in liters. Okay, so that is what you're asked to do to convert cubic centimeters to liters. Okay, so as we know that there is a great relationship between cubic centimeters and milliliters. That's what we actually know in this case. All right, so if you're given cubic centimeters, you can relate them to liters. That's what you can have. So we've got a cubic centimeter, which is equal to 1 mil. So this ratio, or this proportion is 1:1. When we have got 1 cubic centimeter, you have got 1 mil, 1 milliliter, which you can convert this to liters, because you know that in a liter you have got 1000 milliliters in this case. Okay, so since a cubic centimeter is equal to 1 mil, then what about 2460? 2460 cubic centimeters is going to be equal to what? It's just going to be equal to direct 2460 mils, because this is just 1:1. So if this is 1:1, so if this is just 1 and the same thing, and we can convert now 2460 mils, because this is same as 240 mils, because there is a relationship that you can take from there to convert to liters. So what are you going to do? Definitely have to divide. This is going to be 2,4. Okay, let's just do it stage by stage. Maybe I'm rushing here. Let us just do it stage by stage so that we move together. So we are going to have 2460 mils over 1000. So it's going to be over 1000 mils. So these two, they divide each other. Then you're going to multiply by 1 liter. Okay, so as you can see, the mil and the milliliter here is going to divide, and you've got 0 and 0 here is going to divide, and you're left with 2 zeros. That means we are just going to move 2 decimal places to the left. This is your dividing, guys, this paper 1. So you just move 2 decimal places. That is 1, 2. So your comma is going to be somewhere there. That means our final answer is going to be 2,46. So you're going to have 2,46 liters in this case. So take note, this is a comma here. So it's going to be 2,46 liters. Okay, so that is the case that we had. And on B, we are given to convert or to express 1 hectare as a percentage of 0.25 square kilometers. This is square kilometers. Okay, so as a percentage, we are simply saying 1 hectare over 0.25. This is 0.25 square kilometers that you are going to have in this case. So it's going to be 0.25 square kilometers, 0.25. Okay, square kilometers multiply by 100%. All right, but as you can see, these units are not the same, so you can't do anything here unless you're having the same units. Here you're given a hectare, and these are square kilometers, so we have to convert to the same units. And which units can we use? We can take advantage of knowing that in a hectare we have got 10,000 square meters. So that means we can convert this to square meters, and we can also convert 0.25, because remember I told you that, guys, in a square kilometer you have got 1 million square meters. So you've got 1 million square meters in this case. So if we got 1 million square meters, that means we are just going to divide by 1 million. Where is this coming from? Remember, you are just taking this from a kilometer. Remember, in a kilometer, you have got 1,000 meters. So all you need to do is to square both sides. So we're going to square both sides in this case. We're going to have 1 square kilometer equal to 1 million square meters. So that's where it actually came from. You just square both sides. So in this case, if 1 kilometer is 1 million square meters, what about 0.25? We are now asking ourselves to say, what about 0.25 square kilometers? What is it going to give us in square meters? Since we have expressed 1 hectare in terms of what? In terms of square meters. So definitely have to multiply 0.25 over 1. So it's this divided by 1 here, multiply by 1 million. So you're going to multiply to 1 million square meters. Okay. Multiplying by 1 million simply means you're moving what? 6 commas to the right. That is to the right this case. So let's just have it here and see what you're going to have at the end. It's 0.25. 0.25, not 28. So this is 0.25 here. All right, so that's a 5. And if we multiply by 1 million, we are simply saying, let's move how many commas? 6 commas to the right. So it's going to be 1 here, 2, 3, 4, 5, 6 to the right. So in each and every groove that we have, we are going to put a 0 here. In each and every groove, that means here there's a 0 here, a 0 here, a 0 here, and a 0 here. So our answer is going to be 2, 5. How many zeros? We've got 2 4 zeros. So it's 1, 2, 3, 4. So this is going to be 250,000. Okay, so that is what we're going to have in square meters for this 0.25. So 1 hectare. So these units you're supposed to know them. You're not supposed to waste much time converting like this. Okay, you're supposed to know these units. So 1 hectare here, we are now going to replace with 10,000 square meters. So it's going to be 10,000 square meters, everything over 0.25 square kilometers, which is 250,000. So this is 250,000 square meters multiplied by 100%. So as you can see, the units are the same, so you can cancel out these units. And also we can cancel the zeros here. I've got 3 here, 3 here, 1 here, and 1 here. So 25 into 25 is 125 into 100, which is 4. So definitely our answer is going to be 4%. That's 4 times 1, which is 4%. So it means 1 hectare is a percentage of 0.25 square kilometers is 4% of it. Okay, then on question 2a, we are asked to evaluate, in this case, -8 to the exponent of to the exponent of 2 over 3. So we know that from our laws of exponents, x to the exponent of a over b is going to give us the bth root of x to the exponent of a. So this is going to be our b in this case, which is 3. So it's going to be the cube root of -8, and everything there is going to be to the exponent of 2. So all we need is to simplify. What is the cube root of a? The number that multiplies itself 3 times to give us -8 is going to be a -2. -2 times -2 is +4. +4 times -2, which is -8. So the answer for the cube root of -8 is -2 to the exponent of 2. And -2 times -2, that's a 4 here. As we said, -2 times -2 gave us a 4. So which means -2 squared is going to give us a 4 at the end. All right, so our answer in this case here is going to be a 4. So I just hope, guys, we are seeing what is happening here so that at least it can help us to attempt these typical questions. All right, so that's a 4 there. Let's move on to another part of the question. Simplify square root of 147 plus square root of 108. Leave your answer in the form of m square root of n, where m and n are integers. Okay, so remember guys from your says that for you to add, you can't add these numbers in set form unless the numbers under the square root are the same. You can only add when the numbers under the square root are the same. These must be the same. So at least let us simplify this in simplest form. What is square root of 147 going to give us? Remember, if you know this direct, yes, you can just apply this direct because you know that 47 is going, 147 is actually 49 times, this is 49 times what? Times 3. Yeah, 49 times 3 gives us 147. So it means we just have square root of 49, which is 7 square root of 3. But if you do not this, then you have to do the longer procedure that I talked about previously, where I said you can write this 147 as a product of its prime factors. That is 147 as a product of its prime factors. So the smaller number here is 3. 3 into 14, that is into 12, it's 4, and there is a remainder of 2. Into 27, that is 9. Here we can't use 3, we move on to 7. 7 into 49, that is 7. 7 into 7, which is 1. So this is a 7 here. So as you can see, I told you that when there is a pair like this number that here has got a pair, you write it outside of the square root. So it's 7. And this number 3 has no pair. It does not correspond with any number. So you write it under the square root. So that's square root of 147. So which means here we are going to have 7 square root of 3 plus we move on to 108. So we are going to do the same on 108. Okay, so let's try the shorter way, just like what we did from the previous question that we had, so that at least it can help us. So in this case, 108 is same as a square root of 36. This is 36 times 3. Yeah, if we multiply this, it's going to give us 108. And 36, square root of 36 is 6, but we do not know square root of 3. So it's going to remain like that. Okay, or if you don't know this part well, then we have to do the longer way, 108, like this. Okay, I think we have managed to win. It's now at the end part, guys, and I hope I'm just going to win here. Okay, anyways, that's what you're gonna have here. Let's just divide. All right, divide by 2. That's the smaller number. 2 into 10, that is 5. Into 8 here, that is 4. By 2 again, 2 into 5, that is 2. Remainder 1, which is into 7. Into 14, that's 7. Okay, so you can move on to 3. 3 into 27, that is 9. 3 into 9, that is 3. 3 into 3, that is 1. All right, so let's pick out our pairs and see the number that has got pairs. Remember, I told you the number that has got pairs, you write them out of the square root. So we've got 2 here, and we've got 3. These have got a pair. So 2 and 3, they are going to be written outside of the square root, and we are just left with this 3. You write it inside the square root. So it's going to be 2 times 3, which is 6 square root of 3. All right, so that means we managed to work out this and obtain the 6 square root of 3 from this. We are going to add 6 square root of 3. So like I said, you choose which method. Are you going to do the longer way, or you're just going to use the shorter way, this one? Okay, so anyways, when you're at this stage, as we can see now, the numbers under the square root, they're actually the same here. We are having square root of 3, square root of 3. So that means we can add these numbers. Remember, once these are the same, it means you are now able to add these numbers here, 7 and 6. These are the numbers that you add. So 7 plus 6, that is 13, if I'm not mistaken here. So it's going to be 13 square root of 3. All right, so that's what we just needed there. And as you can see, guys, it's pretty easier. If you work with many questions, it's going to be pretty easier to understand. Okay, number 3, we are given to solve the simultaneous equations. All right, so this time, guys, I'm just going to use the elimination and substitution method, elimination by substitution, because here we can see that, yeah, I did substitution in our previous video. So here I'm just going to work with elimination. So I just want to eliminate here this part of X. So let me indicate the part that I'm going to eliminate here. We've got 3 and we've got 5. So remember, we have to interchange these numbers, multiply by 5 on top, multiply by 3 in the bottom here. So 5 is going to multiply each and every term throughout this equation. So it's 5 times 3, which is a 15x. So 5 times 3, that's going to be 15x in this case. Let's see what you're going to have. So you said this is going to give us 15x. 5 times minus y, which is going to give us minus 5y, which is equal to 5 times 2 here. There's a 2, 5 times 2, that is 10. All right, we are done with 5. We move on to 3. Just multiply 5 here. So it's 15x minus 3 times 2, which is 6y, is equal to 3 times 0, which is a 0 here. So this is a 15, not 18. This is actually 15. So that's what you're going to have in this case. So you said this will be 15x. Okay, so as we can see, guys, these are now the same. So what are you going to do? X and x are the same, so let's just subtract, because this is positive, this is positive, the signs are the same. So subtract the second equation from the first equation. So it's 15 minus 15, that's a 0 here. And we move on to minus 5. Let me just put it this way so that we can understand what is happening here. So this is negative 5y like this, minus, which means we are talking of this minus here, and you subtract 6y, but as you can see, 6y is already having a negative. So it's negative and negative, which is a positive there. So it's going to be minus 5 y plus 6y, and minus 5 plus 6, that's 1y, which is 1y is same as y. So we're going to be left with y here, which is equal to 10 minus 0. 10 minus 0 is going to be a 0. So y is equal to 10. And if y is equal to 10, then we can substitute into any one of the equations that we just need. We just have to substitute here and see what we are going to have at the end. So you pick any one of the equations that you want. So in this case, I'm just going to choose the first equation, 3x. That's what we have on our first equation. That's 3x minus here. In place of y, now you're going to substitute y, which is what? Which is 10. So it's going to be minus 10, which is equal to 2. So now let's solve for x. What are you going to do here? 3x is equivalent to minus 10 to the other side of the equation is going to be a plus. So this will be plus 10. So 2 plus 10, which is 12. Divide by 3, divide by 3, both sides. So that means x is going to be equal to 3 into 12, that is 4. So this the values that you're going to have, y, which is 10, and x, which is equal to 4. So that's it, guys. You can prove by substitution or any other method of your choice, you're going to obtain the same thing actually. All right, so number 4, we are given q is equivalent to minus 6. So this is minus 6 that you're given. R is equal to minus 1, and we are given T is equal to 2. That's what you're given in this case. So the first equation is to simplify QR over T. So this one is just a matter of substituting, guys. In place of Q, our Q in this case is negative 6. So it's negative 6 times, that is 6 QR. It's a Q times R, that is QR. So our R in this case is minus 1, everything over T. So in this case, our T is 2. So you substitute the value of T here, which is 2. And this is going to give us a negative, that's a positive. So it's going to be positive 6 over 2. And if you simplify, this is going to give us 3. So our answer in this case was a 3. So if you are working with this type of equation, is just a matter of what? Of substituting the values that you are given. Is even here, if you are to cross-check, it's QT minus R. So you're just going back here. Your Q is minus 6. So Q here is minus 6. So it's minus 6 times T. Okay, so we are substituting the value of T. So that is gonna be minus 1. That is T, which is in this case it's a 2. So it's going to be 2 in this case. Okay, so let's just put this in a bracket so that it won't disturb us. Minus R in this case, if you have to get back here, our R is -1, as you can see here. Your R here is -1, so you're going to substitute -1 in this case. Okay, so there is a minus here, which is of the formula, okay, which is this one that we just wrote, but our R is a -1, so it's going to be a -1 like this. Okay, so let's multiply and see what you're going to have. -6 by 2, which is -12, minus and minus, which is a plus in this case, so it's going to be +1. And if you combine this, it's minus a 12 plus 1, which is negative what? Which is -11. All right, so that's what you're going to obtain in this case. Let's see the other one. It's q plus r to the exponent of t. Okay, so this is t. Q plus r to the exponent of t. So it's just a matter of substitution, guys. You're just substituting whatever that you're given. In this case, your q, which is -6. All right, so q is -6 here. So that means this is going to be -6 plus r. All right, and our r in this case, if you have to cross check, our r here is -1. So it's plus -1. So it's going to be plus -1 like this. Okay, so let's put everything in a bracket, because here is in a bracket and it's to the exponent of what? Of t. And our t in this case is 2. So if you cross-checked well, our t here is 2. So that means we can simplify. Take note, guys, plus and minus here gives us a minus. So it's -6 minus 1 to the exponent of 2. And if you are to simplify this, we are going to obtain -7 to the exponent of 2, which means we are going to have 49. Remember, it's -7 times -7, which is 49. Okay, so that's what you're going to have in this case. All right. On number 5a, we are given to state the order of rotational symmetry of a rhombus, the order of rotational symmetry of a. So if you have to cross-check with the rhombus, guys, this is actually something of this nature. So actually a rhombus is just a square. It's just a square that has been shifted up like a shear, out of a shear, because we know that these sides, all of them, they will be equal. Okay, so when you are referring to the order of rotation, you are saying if you rotate this shape 360 degrees, how many, like, when is it going to remain like this? How many times is it going to remain the same way it looks like? Okay, so here is going to have two ways. If we are to rotate this, you are going to see on this side here and on this side, if it is rotated, it's going to be the same shape as it was. That is what you are saying. Because if you're saying order of rotational symmetry, it remains the same shape as it was, like it remains with the same properties as it was before. So a rhombus has got two. It's because of the PDF I can't even rotate properly, but I hope you understand what is happening. On number 5b, we are given that there are 4 interior angles of a 12-sided polygon. Okay, so this is a 12-sided polygon, each x degrees, but how many of them? There are 4. Each is having x degrees, so which means you're talking of what? 4x, like that. Okay, the other angles are each 2x degrees, which means out of 4 angles, out of 12, the ones that we had, we have got 4 that we have taken. So how many are going to remain? Because we're talking about the other, which means the remaining one. The remaining one. Okay, so what is going to be the remaining part in this case? We are going to see that out of 12, we subtract 4. So that means you're going to be left with 8. So each of these 8 is 2x. So it's going to be 8 multiplied by 2x, like this. Okay, so this is actually an expression that we have for the sum of angles. These are the sum of interior angles, sum of interior angles of this polygon that has got what? That has got 12 sides. Okay, so the question is for us to find the value of x. So what we need is that since these are our angles, the sum of these angles, but in terms of x, let us also find the sum of these interior angles of this polygon. So the sum of interior angles, we know is given by n-2 times 180 degrees. This is now the numerical value. So here we are going to find the numerical value. Here we've got an expression. Now we need the numerical value, okay, which is actually the exact answer in terms of what? In terms of the number. So our n in this case is 12 sides. So it's 12 minus 2, which is 10 times 180. And if you multiply, this is going to give us 1,800 degrees. Okay, so these are the sum of angles that we have, which is 1,800. So it means if we are to add these two that we obtained here, that is 4x plus 8 times 2, which is 16x. We must obtain the sum of what? Of 1,800. That is what it means. All right, so it's now back to your normal equations. It's you and your equations, guys. So you can add 4 plus 16, which is 20x, is equal to 1,800. All right, so this is equal to here, sorry for this. So it's going to be equal to 1,800. Okay, so this is equal to 1,800. So divide by 20 both sides. We have to divide by 20 both sides. That means we can cancel this. X is going to be equal to what? This can cancel here. 2 into 18, that is 9. 2 into 0 here, that is 90. So x is going to be 90 degrees. Okay, so guys, these are the typical questions where you have to formulate an equation with the information that you're given, because you're given a certain information, okay? Then you formulate that equation from what? From the information that you're given, depending with the type of question that you have got. So it depends, guys. Number 6A, you are given to calculate 2/3 of 54 kilometers. 2/3 of, remember, of simply means times. That is what of means. So you simply have to multiply, in this case, that is 2/3 of, that is times 54 kilometers. All right, so this is 54 kilometers here. All right, so if we are to have this, we can just reduce, guys, each and every part by 3 here. 3 into 3, that's 1. 3 into 5, that's 1, remainder 2. Okay, 3 into 24, which is something like 8, from 8, 16, 24, yeah. Then we can multiply 2 times 18, which is 36 kilometers. Okay, so it means 2/3 or 54% is simply what? Is simply it is simply 36%. That's what we needed there. That's it. Kim, Munashe, and Chipo shared sweets in the ratio of 5:3:7. So these are guys who are sharing the sweets here. We have got Kim to Munashe, to Chipo in this case, which is this ratio 5:3:7. So this is 5:3 and S/7. So the question is to calculate the number, the total number of sweets shared if Chipo got 35 sweets. Like Chipo here with a ratio of what? Of 7. Chipo has got a ratio of 7. She got 35 sweets. So what about all of these guys? How much did they share? The number of sweets, because we need the total. So we are going to take the total ratio. We are going to add 3 plus 7, which is 10, then plus 5, which is 15. So 15 is the total according to ratio. 7 is the ratio for Chipo. That is why we have to equate to the number of sweets for Chipo, because Chipo have got 7 according to ratio, and she got 35 sweets. What about 15, which is their total ratio? How many now? How much are they going to have in this case? So as you can see, it's a simple proportion, which is going to give us more here. So it's 15. What we want is 15 over what we are given. So it's 15 over 7 times 35. Okay. So 7 here is 1. 7 into 35, that is 5. Then we can multiply 15 times 5, which is going to give us something like what? 75. Okay, so if you multiply proper, that's 5 times 5, which is 25, and we've got a 2. 5 times 1, which is 5, plus 1, which is 75. So which means all together, these guys, they shared 75 sweets, and out of 75, Chipo got 35. Okay, she was the one with the highest, the biggest ratio, so that's why she got a number of sweets which are many than others. Okay, then another part that we are given On number 7a, the Venn diagram consists of the universal set, that is universal set, and subsets P and Q with their respective sets and so forth. Okay, so the first part is to list the elements of P complement. This is P complement here, intersection Q. Okay, so remember, guys, if you're, I talked about this from your sets, if you're given two sets like this, all right, you can easily take your P complement and intersection Q, P complement intersection Q, that is this region here. This is the region that we need if you watch from your sets, which means we need these numbers here. That is our P complement intersection Q, which is 7 and what? 7 and 8. So in this case, we have got 7 and 8. Yeah, this part of sets, if you have a challenge, guys, you can watch the introduction of sets there. I talked about this and how to find this part. Okay, so the other part is number of elements in P union Q complement. So P union Q complement, which means not in P union Q, which is not, it's not part of this set. Okay, so all we need is to know our P union Q. And remember, P union Q means the combination of these two when they are combined together. Okay, so this is your P union Q, this one, that's your P union Q. So the complement, which means outside of this, and what we have outside, we've got 1, we've got 2, we've got 9, we've got 10. That is our P union Q. What is not part of this set, but it's in the universal set. So we've got 1, 2, 9, and 7. So this is what you're going to have in this case. So our set is going to be 1, 2, we said 1, 2, 9, and 10. So these are the numbers that are outside. So it's 9 here, and it's also 10. So complement, which means not part of that, it's not in that set, but it's in the universal set. All right, so just like that, guys, we are done. And this question now is to describe the shaded region in the, I can't see the shaded region. I don't know what happened on this question here, because you're asked to, I don't know which part was shaded. So here is actually a question mark. I don't know, guys, what was actually shaded there. If we have, then let us send the picture on my WhatsApp so that at least we can maybe redo it on a separate part. Okay, an 8a factorized completely. That's x squared minus 1 over 4. Okay, so x squared minus 1 over 4, as we can see, this is actually from our difference of two squares. Why? Because we can write this 1 over 4 here as a like as a square. It's a square. We can write it in this form because remember, a squared minus b squared is supposed to give us a plus b, a minus b, like this. Okay, that's your difference of two. As long as these numbers are being squared, that's what you're going to have in this. All right, sorry for this. Actually, where there's a lot of noise, and I hope it's not going to be like this. But anyways, let's see here. We are going to have, yes, going to be x squared, as we can see. So it's x squared minus this 1 over 2. 1 over 4 here can be written as 1 over 2 squared, so that it gives us 1 over 4. So this is same as 1 over 2, like this squared. So I said if you can write in this form, it means we can have a plus b, of which our a is x and our b it's 1 over 2. So it's going to be x plus 1 over 2 in this case into x minus 1 over 2 in this case. All right, so that's what you're going to have at the end. It's just a matter of knowing your difference of two squares. And this type of equation, if you were to cross-check it nicely, you see that, okay, there's a part that is missing here. Okay, you see that already they factorized another part for us here. It's like you're supposed to factorize, but already we are given x into x. Already they factorized for you here. So you're just doing a continuation here to make sure that these brackets are the same. So what are we going to factor out here between these two? I can see that negative, because x is supposed to be a positive and there is a negative here. So I'm going to factor out negative 2y here. Yeah, 2 is common, y is also common. So negative 2 and negative will cancel, and we are going to be left with x here. 4y here, that's 4 divided by negative 2 is going to be negative 2. Y and y will cancel. So as you can see, guys, these brackets are the same. So we just have to take one of this bracket, which is x minus 2. We factor it out, then we are left with x and minus 2y. So it's going to be x minus 2y into another bracket, just like that. Okay, so that was it, guys. To factorize, here's was direct, and write down or to express in powers of 5. So we know that here we are in base 5, so we're going to have 5 to the exponent of 0 here, to the exponent of 1, to the exponent of 2, to the exponent of 3. So it's going to be 3, 2. We are writing in powers of 5. So it's going to be 2 times 5 to the exponent of 3. The first one is 3 here. Put it in a bracket, plus we move on to 2 here. So it's 2 times 5 to the exponent of 2. This one will be 2 here. Put it in a bracket. We move on to 1. So it's 1 times, so it's going to be 1 times 5 to the exponent of 1. Put this in a bracket, plus we have got 4 here. So it's going to be 4 times 5 to the exponent of 0, like that. Put that in a bracket. Okay, so that is the expanded part. Remember, this is the format that you do when you are converting to base 10. If there is a condition that you are expressing this or you're converting to base 10, you raise in terms of power. But this time you're not simplifying, you're just going to leave your powers like that. Okay, that was the case that we had. And find the value of n given that 1, 0, 1 base n is equivalent to 3, 7 in base of 10. All right, so this is in base of 10, and we know that the only thing that we can do is to convert this also so that it can be in base of what? It can be in base of 10. So we have to raise in terms of the exponents, which is the same thing, 0, 1, 2, just like what we did in the previous part. So we are going to raise in powers of n, which is 1 times n to the exponent of 2, okay, plus we move on to 0 here. So it's going to be 0 times, which any number times 0, guys, we know that that one is just a 0 here. So it's 0 times n to the power of 1, plus here we've got 1. So it's 1 times n to the power of 0, like this. Okay, which is going to give us 37 in base 10. So remember, by doing this, your answer is now in base 10. So we are just going to write 37. There's no need for you to write base 10 because now you want to solve. It's now an equation. So this is just 37 for you. Okay, of which n squared times 1 is just n squared, plus any number times 0 here, that's a 0, guys. Any number times 0, that's going to be a 0 here. N to the power of 0, that's 1. 1 times 1, which is 1. And this is going to give us 37. So depending with the way that you want to solve it, you can transpose 1 to this side, you can transpose 37 to this side. It depends with what you want. In this case, I'm just going to transpose my 1 to this side of the equation. So it's going to be a -1. So it's 37 minus 1, which is 36 in this case. So how do I remove this square here? I have to introduce the square root both sides, knowing that square root of any number is a plus or minus. But in this case, we are referring to n, which is a base, and our base cannot be a negative. So therefore, our value of n, the one that we need, is going to be a positive. That is the n that we actually need on your answer here, which is a +6. So here, like I said, on this part, we are supposed to, on solving this part, you could have transposed 37 to the left-hand side on this side here. So it was going to be n squared plus 1 minus 37, which is equal to 0, like this. So it's n squared 1 minus 37, which is minus 36, which is equal to 0 here. So you can apply your difference of two squares, since 36 is same as 6 squared. So it's going to be n plus 6, n minus 6, which is equal to 0 here. So each bracket is equal to 0, so n will be minus 6, or from this bracket, n is going to be a +6. So as you can see, we are obtaining the same values. Okay, that was it. Then number 10a, P is a 2 by 3 matrix. Q is a 3 by 1 matrix. Then P and Q multiplied together, they give us matrix H. State the order of H. Okay, so remember, guys, I told you that you can state the order not by multiplying, by knowing this order of the matrix that are multiplying. P here, it's a 2 by 3 matrix. which is multiplying Q, which is a 3×1 matrix. So remember, guys, I told you that when these numbers are the same, it means multiplication is possible. And the resultant is going to be these two numbers which are remaining, which is 2 and 1. So which means H is going to be a 2×1 matrix. So it's going to be of order 2×1. You take from these, if these two are the same, then those terms, which is the first term and the last term, become the order of your answer or the final matrix. All right, then we've got find A squared from matrix A that you are given. And as we know, guys, if you're given matrices, matrix A simply means matrix A times matrix A. So that's gonna be 3, 2, 3. This is 2, 3 here, matrix A times matrix A. It just multiplies itself here. So it's going to be 2, 3, 1 minus 3. Okay, that's your matrix A. It multiplies again itself, which is 2, 3, 1 minus 3. Okay, so that's your matrix A. So back to your multiplication, we know of row by column. So it's going to be this row by this column here, which is 2 times 2. So if you multiply 2 times 2, guys, all right. So it's 2 here. All right, so I actually reduced because of this. It was now under this. Okay, so let's see. It's going to be 2 times 2. All right, which is 4. So you're going to have 4 here plus. We move on to 1 times 3. Which is a 3 in this case. Then you are done with this row and this column. So we move on, still on the same row, but now on this column. This is the column that we have. So it's 2 and 1 here, which is 2 plus 1 times minus 3, which is minus 3. Okay, you're done on this row. Then you move on to this row and this column. So it's 3 and 2, which is 6 plus 3 and 3. Minus 3 and 3, which is going to be negative 9. All right, so that's what you're going to have. Then this row and the last column, which is 3 and 1 here, which is 3, minus 3 and minus 3, which is going to be a positive 9. So take note, minus and minus, that's a positive. So from your addition, so always when you're dealing with matrices, you will just see that it's a matter of your addition. Those directed numbers, you're supposed to know them. 4 plus 3, that is 7. 2 plus minus 3, plus and minus gives us a minus, so it's going to be 2 minus 3, which is minus 1 in this case. 6 plus minus 9, that's a minus, so it's 6 minus 9, which is going to give us minus 3. 3 plus 9, which is 12. Okay, so this is what you're going to have at the end as your matrix. Okay, so that was actually the answer from this concept. So as you can see, guys, matrices is all about the language and also knowing how to do your matrix multiplication and so forth. That's what was important in this case. On number 11, we're given this is a circle geometry, and this angle here is 30 degrees. That's what we had. And also, do we have any other important thing that we are given? The parallel lines. Okay, so this is 30 degrees here. We have got the parallel lines here. And it also is a circle which is at center O. So if this is the center O, then that means our A, C is a diameter A. C is a diameter here, and we know that a diameter subtends an angle of 90 degrees at the circumference, which means the angle at D here is going to be a right angle, which is 90 degrees. And also the angle at B here is going to be a right angle, because they are subtended by what? By the diameter. So this is 90. And this is also 90 here. Okay, we have got the parallel lines that we have. OD is parallel to BC. So if these two are parallel, what do we know about parallel lines, guys? We know a lot there. The angles that are the same here, the angle at D, this one that I'm indicating here at D, and this angle here at B, they will be the same. Why? From our Z angle, which is alternate angles, the ones that give us a Z like that. Okay, so this angle here and this angle here are the same. All right. So the question was to calculate the first part of the question, which is a ODB. Okay, so this is ODB, which is ODB, which is actually the one that we have indicated. This one, this is your ODB. All right, so what are you going to do, guys? ODB, we say these two are the same, but if you have to cross-check this angle here at B and this angle here at A, they are the same. They are made or they are subtended by the same chord, which is the chord DC. DC creates an angle here. Let's see if I'm going to win with these things here. Are they going to help us? From D here, this region, this angle, is the angle that I'm saying here, the angle here and this angle are the ones that are the same. Okay, the ones that I'm just indicating there, those two angles are actually the same. As you can see, they are subtended by the same chord. So it means they are going to give us the same value. So this is 30 degrees also at B. But we are saying that the angle at B is the same as the angle at D here, which is also 30 degrees. Why are we saying these two are the same? That is the principle of what? Of alternate angles, the one that we described here from our Z angles. So definitely our ODB is going to be 30 degrees. Okay, so that's our ODB here, which is 30 degrees. All right. Then ABD, this is BD. Let's get back to our diagram. A, B to D. This is A, B, D, which is this angle here. All right, so this is the angle that we want to calculate. That's our ADB. Which concept are we going to use, guys? Remember, we said before, the whole of this angle is 90 degrees. The whole of this angle at B is 90 degrees. And now we know that this is 30 degrees. So we are just going to subtract 90 minus 30. Okay, so that is going to be 90 degrees minus 30 degrees in this case. So it's 90 degrees minus 30 degrees, and 90 minus 30, which is going to give us 60 degrees. Okay, just like that. So that's what you're going to have. So it means this angle here is 60 degrees. Let's just indicate. It might help us anyhow to find another angle. And we are given ACB, ACB. Okay, angle ACB, that's so, guys. ACB, yeah, that is what you're given here, ACB. So let's just indicate our shape angle and see what you're given, ACB, which is this angle here. Okay, so what are you going to have, guys, from this angle? One thing that we actually know, guys, is that here, there are so many ways that you can actually do. I want you to try, because this angle is the same as this angle at D, this one that I'm indicating here. Yes, they're the same, but how can we find if this angle is going to be a little bit difficult for us to find this? Okay, now let's have change of plans. Let's have this from D to O. Here to see this angle that is created at O here is the same as the angle that is at C. We are creating a Z here from D to O here to C and to B here. We are creating a Z, as we can see. So that's a Z which is being created like this. Okay, so this angle and this angle are the same. So we can take advantage of this angle here at O. Why? Because we know that angle at the center is twice angle at the circumference, provided that they are made by the same chord, which is DC. So DC is creating an angle at the center at O, and DC is also creating an angle which is at the circumference here at what? At A. So these two, they have a relationship that at the center is going to be twice. So which means angle D or C, which is the one that is equal to the angle that we want to calculate, which is ACB. These ones, they are the same. But this DOC is twice, because it's the angle that is at the center. It is twice the angle at the circumference, which is this 30 degrees, or you can also use this 30 degrees. It's one and the same thing because they are all made by the same chord. So it's times 30 degrees here, which is going to give us 60 degrees. All right, so what it means is that if this angle here is 60 degrees, this angle here is also 60 degrees. Okay, so that's what we had, guys. So this is going to give us 60 degrees here. I hope we understood this concept. Yeah, sometimes it might not be direct. We have to apply those techniques that we know, guys, from your mathematics and so on until you win. Okay, number 12, we are given, that's a part of construction which was done. They constructed something for us, which is this part here. And from this construction that we have, we are given that the diagram shows triangle AOC and the circle. with center OC 4 centimeters. That is OC here from O to C. That is the radius of the circle. It's 4 centimeters, which means it's the same thing from O to this point is also 4 centimeters. Okay, then the line L is perpendicular bisector of AO. Okay, this line L here is a perpendicular bisector, means it divides AO into 2 equal parts and it's perpendicular. It's at 90 degrees, as you can see, guys. It's direct like that. Okay, so the question is to describe the locus. Take note, guys, describe fully the locus represented on the diagram by the circle. Okay, what does a circle represent? Remember, guys, I told you a circle represents locus of points which are equidistant from a fixed point, and our fixed point in this case is the center O. So in this case, we have got a distance from the center to the circumference, which is 4 centimeters. So it means we drew a circle of 4 centimeters from what? From O. That is how you describe a circle. So the locus of a circle, this you can write it as it is the locus of points. The locus of points here. It is the locus of points that guys, this software is not good. It's a locus of points that are 4 centimeters from O, 4 centimeters from O, which is the fixed point, which is the center from O, which is the center. Like if you are to given, maybe you're given 2 centimeters from, as long it is from a point like this, A is a point, you draw a circle from that point A, which is 2 centimeters in radius. So that's how you describe a circle. Okay, what about the line L? So we want to see the locus which represents line L. And line L here is this one, which is a perpendicular bisector. It bisects what? AB. So from our locus, we know that is locus of points equidistant from A to B. Okay, so the line L is simply the locus of points. So this one is simply locus of points, equidistant. So this is equidistant from A to B, from A to B, or you can write A and B. It's A to B here. Is it that so? No, it's O to A. From O here, this is your O to A. It bisects line OA, so it's going to be from O to A. So you write the one that is being bisected. The line that is being bisected is what? Is line OA. So it's going to be O to A. All right, so that is it, guys. As you can see, it's just 1 mark. So make sure also you watch the video on locus. I represented 4 loci which are important in your syllabus, and you have to know all of them. Okay. On number B, we are given that P is both inside the circle and inside triangle AOC. Let's start by that. This point that we are talking about, it's inside the circle, okay, and also inside the triangle, which means we are talking about any region that can be here, 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 as long it is inside the circle, which means this one is not taken because it's totally out, because it's outside of the circle. Yes, it's inside the triangle, but it's outside of the circle. So this region is out. We need a region that is inside the circle. Okay, and that region that is inside the circle and also inside this triangle, it is nearer to A than to O. So show by shading the region in which P must lie. Okay, this region is nearer A than O. So let's cross-check. The line L here is the one that divides, that can tell us which region is closer to A and which region is closer to O by this line. So we are told that the region is closer to what? The region that we are talking about here is closer, is nearer A than O. So it is nearer A than O. Take note, guys, this part here is inside the triangle and the circle. So this is not inside the triangle, this one is also not inside the triangle. So which means we were just having 2 regions actually. This region, yeah, I can see there we had made a mistake. Okay, so here we just have 2 regions that we have, this region and this region, but which one is closer to A than to all. Definitely is this region here. So that is the region that we are going to have. The region is supposed to be inside the triangle and also inside the circle. So this is not it because it's not inside the triangle, this region. Yes, it's inside the circle, but not inside the triangle. This is also wrong. It's not inside the triangle. Yes, it's inside the circle, but not inside this triangle. So we are just going to be left with this region that I indicated here. So you can write even your P inside, or you just shed that region. So, but the question here was what? Was to shed, isn't it? Yeah, by shading, show by shading. So you just shed. All right, so that was it, guys. Number 13, convert $5, 40 US to South African rand. Use an exchange rate of $1 to 12 rand. So you're given a conversion to use each US dollar is equivalent to 12 South African rand. So what is going to be the amount that is equivalent to $5.40? So you've got $5.40 in this case. What is going to be the equivalent to this amount? So this one is just a simple proportion, as you can see. This one is going to give us more. All right, now let's play around our mathematical skills to calculate this, guys. As you can see, it's going to be this more, which is 5,40. So the 0 there is just for man. If you are dealing with man, you round to 2 decimal places. But when calculating, just leave this 0, does not work for us. Okay, so it's 5,4 over 1 times 12. All right, so what are you simply doing? You're going to multiply 54 times 12. So you multiply 54 times 12, you ignore the comma, everything that you are given, just multiply your numbers. And in this case, you are going to obtain 648 if you multiply properly, 648. Then how many decimal places do we have? We've got 1 decimal place because this is 5,4. So we've got 1 decimal place. So our answer is going to be 64. 80. So remember, you're dealing with money. Okay, these are South African rands that we are now having. So that is going to be the equivalent in South African rands. So the question was for you to find the equivalent that is going to be of $5.40 to South African rands. So that's what you're going to have in this case. Let's move on to B. A farmer borrowed $2,000 at simple interest. So this is the money that was borrowed at simple interest. 20% per annum. Calculate the total amount payable after 2 years. Okay, remember your simple interest, guys. There are so many ways that you can use, but from our simple interest, we know that amount is equivalent to P into 1 plus NI, where N is the number of years and I is the interest as a percentage decimal. So you express this decimal percentage. Okay, so the amount is the one that you're going to have after 2 years. So which means your amount is going to be the principal here. In this case, your principal is the money borrowed, which is 2,000. So we borrowed, in this case, $2,000 into 1 plus N, which is the number of years. So how many years are we talking about? Is 2 years times the interest as a decimal is 20%. So 20% as a decimal, you simply have to divide by 100, which is 0,2. So this is going to be 0,2 here. All right, so apply your mathematical skills. You are going to have 2,000 into, this is 2 times 0,2, which is 0,4. Then we add 1 plus 0,4, which is 1,4. So if you multiply this, so what you're simply doing, you're simply multiplying 14 times 2,000. Ignore the comma, okay? Then multiply these numbers. 14 times 2,000, that's 0, 0, 0 here. 2 times 4, which is 8. 2 times 2 times 1, which is 2. And we've got 1 decimal place, so you just have 1 decimal place because here it's 1,4, just 1 decimal place. So which means we are going to have 2,800. Guys, this is 1,4. Okay, so let's see. That's 0, 0, 0, 0. 2 here, which is 8. 2 here, which is 2. And all right, so I just want you to cross-check. Is it going to be 2,008 like that, or is 2,800? Okay, so let me just cross-check again. Here's 2,000. multiply by 1.4. Supposed to be 2,800. Okay, so it's fine like that. It's 2,800. I just thought another way. So it's 2,800 actually. Okay, so this is going to be your amount here, which is 2,800. So it means after 2 years, the amount that was going to be paid back, which is the payable amount, was 2,800. Okay, let's say maybe I didn't understand this concept and I had to work in to use another way. Maybe I didn't understand what's happening here. What I was going to do, this is simple interest, isn't it? So what you're going to do, you know that you can use this part to say the amount after 2 years, which is the amount, is going to be the principal plus the interest. So you can use this concept. You have the principal, which is the amount that was being borrowed here, which is 2,000, but you do not have this interest. The interest is not there. So you can use that formula for your interest. The one most of you are used to this, where you know that interest is equal to PRT over 100. So it's going to be PRT over 100, which is the principal, which is our principal here. Let's get back to our principal, which we said it's $2,000. So it's going to be $2,000 in this case, multiplied by the rate, which is the percentage rate, which is 20%. This time you write it as it is because already there is this 100 that is there. So you write this percentage as it is. So it's just 20 times the time in years. Make sure that your time is in years, and already it's in years, it's 2 years. So it's going to be 2 here over 100. So that's what you're going to have in this case, the 2 zeros here, the 2 zeros here. So you're left with 20 times 2. All right, so that's 20 times 20, which is 400 times 2, which is 800. All right, so this one is going to give us $800 as our interest. All right. But I said here that the amount that you're going to have at the end, because here you are referring to the amount. That is what is important, guys, that the amount that you're going to have at the end is going to be the principal amount, which is the one that you borrowed. In this case is 2,000. So you borrowed 2,000, all right? Then you are paying an interest of what? Of 800. This is the interest that you're going to pay at the end. So which means you're going to pay back $2,800. Okay, so that was your amount, the one that you're going to pay, which is $2,800. Okay, so that was it, guys. You can use the simple interest formula this way, direct, or you can use the normal that you are used, then you add the interest, but that was important. If it is compound interest, then you use this formula. A is equal to P into 1 plus I to the exponent of n. That is for compound interest, but this one is just simple interest, just like that. Okay. Number 14, we are given, this is, all right, so let's just see, part of a bearing, we are given this angle here is 10 degrees, all right, so this is 10 degrees that we have got, and this is 120, you've got points A, B, and C. In the diagram, let's analyze our diagram and see what we have got there. In the diagram, A, B, C are points on level ground. B is 4 kilometers. This B is 4 kilometers due east of A. It means if it is on the east, remember the concept, guys. This is east, the east line. This is your, so which means it's from point A is going to be in a 90 degrees. This is east. So which means here it means we have got a north pole at A, at B like this, and it continues from this line at A. It's a straight line because this is your A and this is to the east. Okay, from your A here, this is your point A, and you are going to the east of A, to the east this side. Okay, so that means actually this is 90 degrees. The whole of this angle is 90 degrees, and also the whole of this angle here is 90 degrees also. From this 120, the part of this angle here that I'm going to indicate, this one is also 90 degrees because we are going straight. And that can help us to say if the whole of this angle was previously 120 degrees, then what about this angle that is remaining here that I'm indicating here? There's this small angle that is going to remain there. What is going to be this piece that I'm indicating here? So definitely it will be 120 degrees minus 90 degrees of what? Of this part of the right angle that you're given. And that will give us 30 degrees. So it means we have got 30 degrees here. So that 30 plus 90 is 120. Okay, anyways, let's answer the first question. The first question is to state the bearing of B from C. What is the bearing of B from C? That is a B here from. So remember I told you guys from, that's where we have to go at the point C here. We need from this point C to B. What is the bearing from this point B, which means we are going to have this bearing here from C. Remember, you take your bearing from the North Pole in a clockwise direction, which means you're talking about this angle here from C going to B until you reach the line that goes to B. And this is the point that where we are going to reach here. All right. So what are we going to have as our final answer on this bearing? I want us to see that it's a combination. This angle that you're talking about is a combination of two angles. This angle here that I'm indicating and a straight line. Take note, there's a straight line, and we know that angles on a straight line, they add up to 180. What about this angle now that is going to remain here? Where are we going to have this? Okay, if you are to okay, let's just continue this line here. All right, you are going to see these are north poles, and I told you guys this angle here and this angle here are the same. This angle and this angle, they create a Z. As you can see, guys, a Z that is being created there. So which means the angle that we have got at C is going to be 30 degrees here. There is a 30 degrees that is there at this point. Okay, so the complete angle now at C is going to be 180 degrees plus 30 degrees, and this is going to give us 210 degrees. Okay, so the whole of this angle is going to be 210. So that's the case, guys. Okay. That's how you play around these questions. It's just a matter of play around questions. As you can see, it's just 1 mark for that. So I don't know if you actually understand. So that's what we had. Okay, so guys, let us just see the other page here that we have. Using as much information given below. Guys, take note, using as much, which means if this information is not used, then you have done nothing because that information must be used. Okay, anyways, we want to calculate BC. From this information, let us calculate BC. What do we have? What do we have? This is our BC here. So let's just see if this part can help us to just remove this part, because I don't think it's going to help us. These angles, they're actually outside of the shape. So do they help us? No, they don't. They're outside. That angle is outside. So there's no need. Even this part, let's just remove. Let's just clear our diagram and you have a clear thing here. And this eraser, it's like it wants to erase, it doesn't want to erase, or what happened? Okay, so that's what we actually had. So, okay, this part we can just leave it like that. Okay, but that's it. So we want to calculate this side, which is BC. All right. So that's BC, which is this side here. And what are we given? We are given only one angle, okay, two angles actually, because this is 10 degrees, 120, at least 10 is there. On your information, as you can see, there is 10 degrees, 10 degrees, there's 10 degrees, but 120 is not there. If you are given 120 like this, you must at least expect to work with an angle of what? Of 60 degrees, which is on a straight line, because these are on a straight line, so you can use relationship, but we do not have 60 here, so which means we have to find this angle here, the third angle on C, so that it can help us. Okay, so you know that angles in a triangle, they have 180 degrees, so the angle at C is going to be 180 degrees minus the other angles which are inside this triangle, which is 10 and 120. Okay, so it's going to be 10 degrees plus 120 degrees, like that. Okay, so at the end, we are going to have 180 minus 10 plus 120, which is going to be something like 130 degrees. Subtracting this, we're going to have 50 degrees. Okay, so this is 50, guys. I hope now you understand that our software, guys, does not want me to write 50 properly. Okay, just like that, 50. degrees. Now you are back to your solving triangles. What are you going to do? You have the angles and the sides. If you have to cross-check here, this angle this side that you want to calculate BC, it corresponds with this angle here, okay? That is like this. And also the side that we are given, this 4 here that we are given, it corresponds with this angle here of 50 degrees. So that means we can use sine rule. What does sine rule states? You know that sine rule to calculate a side, it's A over sine A. All right, it's A over sine A, which is going to give us B over sine B. All right, this is sine B here. Okay, so it's going to be sine of B. So that's what we have got in this case, whereby these are the angles and the sides. Okay, so the A, the B are the sides, which means in this case, A, in this case, you want to calculate this side, which is BC. This is the side that you want to calculate BC. So it's BC over the angle that is opposite to BC, which is what? 10 degrees. So it's BC over sine 10 degrees like that. Okay, so it's going to be BC over sine 10 degrees. Okay, so it's going to be sine 10 degrees like that, which is equal to what you are given. What are you given? You are given this side of 4, and it corresponds with this angle at 50, which is at C. So it's going to be 4 over sine 50. All right, so it's going to be 4 over sine 50. So someone might wonder, why are we having this? We are in paper 1. That is why they gave you the values of sine 50, whatever that you have there. So you can play around this equation so that you can find BC by simply removing this sine 10. We can multiply by it, multiply by sine 10 degrees here. Guys, this software does not want me to write fast. And I need to write fast because I need to finish this paper, you know. And it want me to write as if, okay, anyways, let me try to correspond with what it wants. So this is sine 10 degrees here. Okay, multiply also this side by sine 10 degrees here. Okay, so this sine 10 and this sine 10 can cancel, and that means we are going to be left out with BC now because you've canceled everything. So your BC is going to be equal to 4 times sine 10, which is 4 sine 10 degrees, everything over sine 50 degrees. Okay, now let's substitute our values. We are going to have 4 times sine 10, which we are given the value of sine 10 here. Sine 10 is equal to 0.2. So it's 0.2 over sine 50. Your sine 50 here is 0.8. So it's going to be 0.8. So you're now back to your calculations, guys. How do you work with decimal? Let's just simplify 0.2 over 0.8. We know that we have to multiply by 10 over 10. So you can do that even here. Multiply by 10 over 10, and this will be 4 times 0.2 times 10, which is 2, over 0.8 times 10, which is 8. You simply move 1 comma here. So 4 times 2, that is 8 over 8. And if you divide this, you are going to be left with 1 kilometer, which is 1. So it's going to be 1 kilometer here. Take note, the units are given in kilometers here, 4 kilometer. So your answer also is going to be in kilometers. That is the case. All right, so you have to be very, very specific with your working and so forth. Okay, anyways, on number 15A, we are given to evaluate the logarithm of 143 in base of 3. So here there are so many ways that you can do. I'm going to work out this one first. Remember, I told you guys you can use this concept because you know that logarithm of A in base of A is 1. Okay, so we are going to write this as logarithm of, let's start by our fractions. Yeah, 1 over 243 from your laws of exponent is same as 243 to the exponent of -1, which is in base 3. Okay, So let us write this number in base 3. 243, we know that this is 3 to the exponent of 5. Guys, where am I trying to write? Okay, I'm supposed to write here. So it's 3 to the exponent of 5, which is going to give us 243. So if you multiply 3 5 times, it is going to give you 243. But there is a negative exponent here. So it's going to be log 3 to the exponent of 5. So it was supposed to be like this: 3 to the exponent of 5 times minus 1, which is going to give us negative what? Negative 5 in base of 3. And we know from this law, P log M is equivalent, I told you guys, it's log M to the exponent of P. So it's going to be, we can drop this number here, which is minus 5. So it's going to be minus 5, the logarithm of 3 in base 3. So this is minus 5 here, log 3 base 3. And we are now back to that condition where we need 8 here. We log A in base of A, we say it is 1. So log 3 in base of 3 is 1. So it's 1 times minus 5, which is minus 5. So your answer in this case is going to be a negative 5. So that's what you're going to have in that case. All right, so it's going to be a negative what? A negative 5 here. It's going to be a negative 5. Okay, so that's it, guys. We could have, yes, done this in another way. Let me just remove this part, okay? We could have done this in another way. Why is it not removing everything just like what it told us that it can remove everything? Okay, so let's see the other part that we could have done, guys. And this eraser is too slow. I don't know how it wants me to erase, like too slow like this, guys. Just imagine. Okay, anyways, I'll try to figure out which is the best one to use as we move on. So let me just put it this way. Okay. Another way that we could have done was to introduce, you remember from your laws of logarithm, you can introduce this concept here. Let me find a space. Where can I write this now? Here. Okay, let's just put it here. Yeah, I think this space can work for us. All right, let's just use this space here. All right, remove this, remove this. All right, so I'm just going to use this space here. We can let this log be equal to x, okay? Let logarithm of what? The logarithm of 1 over 243 in base of 3 be equal to x. We have introduced an unknown value there, where we know this number here, the whole of this number, which is 1 over 243, is going to be equal to the base, which is 3 to the exponent of x. So it's going to be 3 to the exponent of x. All right, so 1 over 243, still we are going back to that thing of introducing a negative exponent. That part does not change. It's just going to be one and the same thing. So it's 243 to the exponent of negative 1, which is equal to 3 to the exponent of x. So you have to make sure that the bases are the same. And we said 3 to the exponent of 5 is the one that gives us 243. So it's going to be 3 to the exponent of minus 5, which is 3 to the exponent of x. We know that when the bases are the same, it means the exponents are the same. So x is going to give us minus what? Minus 5. So on your answer, you just write minus 5. You don't write x is equal to minus 5. Here, on this part that you're given to write your answer, there you just write minus 5. You don't write log this and that is equal to, just write an answer there. Okay, so that was it, guys, on this part. Then we are given to solve the equation. It's a logarithm, which is logarithm of 81 in base of 3, which is equivalent to 2x minus 1. So this one, they are just playing with us, guys. They just want you to simplify log 81 in base of 3. Do you know log 81 in base of 3? Simplify this. I don't know which method they're going to use, but I'm going to use the first method that we did of writing in the format of having log a base a. All right. So it means 81 in base of 3. 3 is 81 is same as 3 to the exponent of 4 in base of 3. So you can drop this exponent just like what we did previously. So it's going to be 4 logarithm of 3 in base 3. So log 3 base 3 gives us a 1. So it's 1 times 4. which is 4. So like I said, you can use any method, guys, that you are capable of. You can use that one of introducing, let the logarithm of 81, all right, let the logarithm of 81 here in base of what? In base of 3 be equal to x. Logarithm of 81 in base of 3 be equal to x. So it's going to be 81 here be equal to 3 to the exponent of x. So we've got 81, which is 3 to the exponent of 4, is equal to 3 to the exponent of x. The base are the same, so x is going to give us 4. So it means the whole thing from this part of log is 4. So you can replace 4 is equal to 2x minus 1. So as you can see, it's now a normal equation that you are used to. You can actually solve from the, or you could have just taken, I don't know the way that, but this was the easiest way because now it's a normal equation, it's just a 4 here. So it's just a matter of collecting like terms, minus 1 to x to 4 here is going to be 4 plus 1, which is equal to 2x. So 4 plus 1, that is 5, which is going to give us 2x here, divide by 2, divide by 2. So you can cancel out each and every term here. So it's going to be 5 over 2 or 2.5. So that's 5 over 2 or 2.5 or 2.5, depending with how you want to have or to write your answer, but that was the case there. And on number 16 is actually a table that you're given. So these are actually the values of h. It's just a normal table, guys. This is just h here, and this is v. So you're given 1, 3, 2, and 24, 3, and 81, and here, and so on and so on here, q, and something like that. Okay. So now they gave us a relationship on this table to say that from this table that we have, the table shows some corresponding values of h and v such that, take note, v varies directly as h to the exponent of 3, which is the cube of h. All right, so the question is now for you to find the equation connecting v and h. Okay, so this is actually a direct variation that you are working with. Remember, if you're working with variation, you introduce the constant of variation, which is in this case, you are going to write it as v is equal to k h to the exponent of 3. So the equation which connects v and h, which means we have to find the value of what? The value of k here by substituting. You just substitute n of these values that you're given from the table. When h is 1, v is 3, or you can use this pair, or you can use this pair. Okay, so we had 3 options to use. This one we can't use because here there is an unknown value. So you can use any one of these, you're going to obtain the same value of k. So what am I trying to say? Substitute into your equation. I'm going to use this first one. V is 3. So I'm going to substitute in place of v, I'm going to substitute 3 is equal to h. At that moment, h will be equal to 1. So it's 1 to the exponent of 3 times k. Okay, so as you can see, you're going to have 3, which is equal to 1 to the exponent of 3 is 1. 1 times k is k. So k is equal to 3. Therefore, the relationship between v and h is going to be v is equal to, in place of k here, we substitute 3. So it's going to be 3h to the exponent of 3. So this is the relationship between v and h. You just need v and h on your final answer. All the other letters must be represented with what? With the numbers. That is, k is going to be 3. So you indicate with that. But if they were you are given that in terms of k, if you are given that in terms of k like this, it means you have to leave it at this stage where you are given v is equal to k h to the exponent. That is in terms of k. But here they need numerical value. You only have 2 letters, v and what? And h. So which means you have to find the numerical value of what? Of k. So that was it, guys. And let's see B. Find the value of Q. So it's now a continuation that you're going to do because already you've got this equation here. V is equal to 3h to the exponent of 3. V is equal to 3h to the exponent of 3 in this case. All right, so that's what you're going to have in this case. So now what am I going to do? I need the value of Q, and the Q is here on this last stage. That is where we have got our Q. When our V is equal to 648. So we are given the value of V and we want the value of Q. So what you're going to do is to substitute V is 648. So this is your V here, 648, which is equal to 3H. Our H in that moment, our H is the 1 here. This is your H here, which is represented by Q. So you're going to substitute Q in place of H. So it's going to be Q here in place of H. It's going to be Q to the exponent of 3. All right, so let us calculate our Q, guys. We can divide both sides by 3 here. That's going to give us something like 2. Okay, let's just divide here. It's going to be 2. 3 into 4, that is a 1, remainder 1, into 18, which is 6. So 216 is equivalent to Q to the exponent of 3. Remove the exponent of 3 by introducing the cube root, both sides, cube root both sides, so this can cancel. So your Q is going to be the cube root of 216, that's 6. 6 times 6 times 6 gives us 216. This is 36. 36 times 6, which is 216. So your Q in this case is going to be a 6. So it's a matter of you, again, knowing your, it is best for you to know this cube root and so forth, all the powers of 3 and 2. It's much better for you to know this. Okay. Anyways, on number 17, we are given, there's a point A with coordinates 4, 2. Is mapped onto A1. So A1 here is the image, is mapped onto. So this is your image. What was mapped is the object. So this is your object here. Okay, this was mapped by a transformation represented by this matrix. This is 1 minus 3 or is 1, 3? It's minus. I don't know the sign that we are given there. It's a minus. So this is a minus here. I'm just taking this as a minus, guys. Just taking, because this paper is not actually, when it was scanned, it was not that clear. So this is a minus. I'm just going to take as a minus. Depend, if it is a plus, it's fine. Use it as a plus, but just going to take as a minus. So this is your matrix here, 1, 0, minus 3, 1. Okay, so the question is, calculate the coordinates of point A, which is A1, the image. Remember I said A1 is the image. And guys, I told you the relationship on matrices using transformation, that whenever you are given a matrix, it's matrix times the object, and you are going to obtain the image. That is the case. Matrix times object is equal to image. So you have got the matrix, so no need for you to worry. Just introduce your matrix minus. This is 1 here, not minus. So it's going to be a 1, 0 here. So it's 1, 0 here, minus 3 and 1. So that's your matrix times the object. The object now is your A. This one is your object, but you write it in matrix form, that is as a matrix. So you're just going to write it in this way, which is 4, 2. So you multiply so that whatever that you're going to get is your image, which is our image is what? Is A1. So let us do our matrix multiplication row by column as usual. So you're going to have this row to this column. So it's 1 and 4, 1 times 4, which is 4, plus 0 times 2, which is a 0 here. We move on to this row and this column again. So it's minus 3 times 4, which is negative 12. So it's negative 3 and 4, which is negative 12 here, plus 1 times 2, which is going to give us a 2. So let us combine everything together. That's 4 plus 0 here, which is 4, minus 12 plus 2, which is negative 10. Okay, so this is going to give us negative 10 actually. But remember, we were given as a point before. This 4, 2, we wrote it like this. So it's the same thing. If you get your answer like this, therefore you write it as a point like this. So A1, which is our point, is going to be 4 minus 10. So that is the point A, which is the image of what? Of point A after matrix multiplication. So that was it, guys. Just know matrix times object gives you the image matrix. That's like that. Okay. Then we are asked to describe the single transformation represented by that matrix. So we said this was a minus if we were not mistaken, because it was not clear. I don't know, guys. Just see. what sign was there. If it is a plus, then correct using a plus. It's just one and the same thing. What we are worried about is the working. How are you supposed to answer these questions? Okay, what type of transformation is this? So for transformation, guys, I don't want to lie, you need to know all the matrices of transformation which are in your syllabus. Okay, but this one I talked about it from your matrix of shear. Remember, guys, we talked about this matrix log key. If you still remember this, we talked about this log key this way, where we said it's a shear that we have got with the y-axis invariant. The y-axis at H01 does not move. So this one, it is a shear. So you describe the matrix by knowing which transformation is it. So it is a shear. So this is a shear that we are having. So it is a shear. And what do we have on our shear? We've got a y-axis invariant because it's supposed to be x here and y. So as you can see, y is not moving. So it is going to be y-axis invariant. Okay, y-axis invariant. All right, this thing of writing, guys, is something else. Okay, but this is invariant. Okay, I hope you see what is written there. That is a y-axis invariant in this case. Okay, anyways, then this k here is your shear factor, and our k in this case is this -3. So that's your shear factor. So in this case, our shear factor is going to be -3, just like that. Okay, so that was it. If it is a shear whereby you are in the x-axis invariant, it's supposed to be low key this way, low key like this. All right, this one is for shear x-axis invariant. So it is a shear x-axis invariant and shear factor k. Just like that, you're done describe. So you must know your matrices, go to enlargement, you must know this k, 00k, which is Cook. So all these matrices must be known. Two-way stretch, which is H hook, which is H00k, this one. So how to memorize these matrices, you must know them. Actually, maybe I'll just do a video on this. Okay, we'll see. Just do a video. Maybe it's going to help us. Number 18, solve the inequalities that we are given. And these are simultaneous inequalities whereby you are given two inequality signs like this. We've got an inequality sign here and an inequality sign here. So how do I solve? I just have to divide my inequality into two. How do I divide? I take the expression or the term that is in between the inequalities. So as you can see, this is the expression between these two inequalities. So you separate this to the first part here with 3x minus 6 is less than or equal to, you take this expression as it is, which is 2x minus 3. Okay, you move on to another part. You separate this. You're going to start this time with 2x. So it's going to be 2x minus 3 is less than 4x plus 1. So you take the sign as it is also. You have to take the sign that you're given as it is. All right, so not wasting much time, let us just try to solve collect like terms. The part with x here, we can transpose this 2x to the left-hand side. So it's going to be 3x minus 2x, which is less than or equal to transpose this 6 is going to be a positive. It was a minus, so it's going to be a positive. So it's minus 3 plus 6. It was a negative, so it's going to be a positive. So you can subtract 3 minus 2, that is 1x, and 1x is just x. So this is less than or equal to 3 from your bottom guys. I mean, from your numbers there, 6 minus 3, which is 3. Then you take the sign of bigger number, which is a plus. Okay, then here we can do the same, but I'm just going to avoid to work with negative. So let me transpose this smaller number to the bigger number, which is 4x, which is a positive. So I'm going to have something like this, 4x minus 2x, okay? So here on the left side, I'm left with what? I'm left with minus 3, and I have to transpose 1 to the left side is going to be a -1. So minus 3 minus 1, that is minus 4, which is less than, remember here, negative and negative, you add these two, then you take the common sign, which is here a negative. So you add the numbers, then take the common sign. 4 minus 2, that is 2x. All right, so you can divide by 2 both sides of the inequality. So it means our x is greater than minus 2. So these are the two solutions that we obtained, but we have to combine these two solutions to give us one unit or one inequality. And always when you combine, your inequality must be in this form, depending with the inequalities that you are given, but it must be in this format. Always try to make sure that your x is in between, then you've got a and b here. So these inequalities depends with the ones that you are given in this case. Okay, so as you can see, this is the one that you're going to take because we are saying our x is greater than a. So always this b is less than a. So always this a is less than b. A is smaller than b. And as you can see, the number that is smaller here, minus 2, is smaller than 3. So we're going to start with this. So it's minus 2 is less than x. So we have taken this part, but from the same x, this one, we can tell that our x is also less than or equal to 3. So the same x is less than or equal to 3. So you have combined the inequality into one. So this is your final answer, which is your solution. So it's going to be x ranging from minus 2 up to positive 3. Then you're asked on B to illustrate your solution. This is on a number line, and you're not given a sketch of a number line, so you're just going to make our own sketch. Okay, so let's just make our own sketch of a number line here. Okay, as you can see, we are from minus 2 up to positive 3. So we are going to start, let's just have our minus 2 here, minus 1, 0, 1, 2, 3. Okay, so what are we going to do? These are the values of x, all right? These are the values of x that you're going to have. And what you're just going to have in this case is we are starting at minus 2. We are starting at minus 2 here. So we are going to indicate at minus 2, we end at 3. So we're going to end at 3. But here, our x is greater than minus 2, but less than or equal. So whenever there is less than or equal like this, you shed that part. Okay, so we're going to shed this part here. So we're going to shed this region. And we are talking about values which are in between these. So definitely you have to join. Okay, I hope you understand, but you have to join that. So here at minus 2, it means this solution is not included. You are going to start from any value that is not minus 2, but 3 is involved. That is what it means. So your number line is just like that. And that's what you just needed to indicate on a number line. Also, you can even indicate other values. Maybe you want to indicate minus 3, you want to indicate 4. Yeah, you can do that, depend with what you want, guys. Okay, number 19, it is given that g is equivalent to the square root of h minus 4 over 4 plus h. Find g when h is equal to 20. So this one was just a matter of what? Substitution, where in place of h, we are going to substitute 20 here in place of h. So it's 20 minus 4 over, in place of h again, we substitute 20. So this one is 5 plus 20, just like that. Okay, so let's just add our numbers here. Subtract, okay, 20 minus 4, that is going to be 16. So it's going to be 16 over 5 plus 20 here, which is 25. Everything under the square root. And also take note from your laws of sets. We know that if you're given square root of a over b like this, we can determine the square root of each separately. Square root of a over square root of b. So which means this one, we can obtain square root of 16 separately, which is plus or minus 4 over square root of 25, which is 5. So answer is going to be plus or minus 5, or just 5, just like that. Okay, just plus or minus, or you can just read. Because these are like when you are dealing with some other topics, that is where it is most important for you to have a plus or minus, but on change of subject, you can even leave it like that. Okay, then express h in terms of g. Okay, so you have to express, which means you have to make this h to be the subject from that formula. Okay, let me just refer our formula again. The formula was g is equivalent to the square root of, it was h minus 4 over 5 plus h. Okay, so this is h plus 4 or h minus 4, it's h minus 4. Okay, so this is h minus 4 over 5 plus h. So what are you going to have, guys, or what are you going to do in this case to make sure that h, as you can see, guys, the h that we need is surrounded by this square root that we have, and we have to get rid of that square root. And what are you going to just do? Square both sides to remove this square root, as we know that the moment I square this and also square this, by just doing this, I have neutralized the square root, is no longer there. So which means I'm just going to be left with g squared. On the left side, I have to find exactly as it is. So it's g squared on the left side. But on the right side, that's where we have neutralized our square root. So we're just going to be left with h minus 4. Okay, everything over 5 plus h, just like that. Okay, so this is going to be h minus 4 over 5 plus h, and we can at least work something from there. We can at least work something from there. This is h minus 4 here. What is it that we can do? We can maybe do cross multiplication. Yeah, just do cross multiplication, because you know this is ms over 1, so that at least you can get rid of the fractions. In this case, taking note, when you cross multiply, you are multiplying each and every term. So the g squared here is going to multiply 5, multiplies h. So it's 5g squared. Okay, let's just put in brackets so that we don't confuse others. So it's going to be 5 plus h, which is equal to 1 multiplies h minus 4. So it's going to be 1 into h minus 4. Okay, just like that, guys, you are done. So you can expand brackets, that g squared times 5, which is a 5 g squared. And we've got g squared times h, which is going to be h g squared, depending with how you want to write it. 1 times this is going to be h. 1 times minus 4, which is minus 4. Okay, so this is an equal sign here. So take note, guys. All right, so from this stage, what are you going to have? We can collect like terms, since we want to make h to be the subject, but we can see that there is h here, there is also h here. So let us collect them to one side of the equation. So we're going to have hg squared minus h, because it was a positive. So once you transpose, it's going to be a negative, which is equal to minus 4. So already here I had a minus 4. So it's going to depend with how actually do you want to have it, guys. It's going to depend with how you want to have it. Like the way that you're going to transpose, it's going to depend with how you want to transpose. Do you want to avoid here working with negative or so forth? So if you take this h, it's going to be negative. And if you take this g squared, it's going to be minus 4 minus 5 g squared. Let me explain this in another way. Someone could have transposed this in this way. We could have done it this way. Okay, maybe I don't want to have this negative. I can avoid that by taking this 4 here, this side, so it can be a plus. So it's going to be 5 g squared plus 4, which is equivalent to, this one is already h here, so it's going to be h minus hg squared. So still we are going to obtain the same expression, but in a different format, like the way that your answer is going to look. So I'm just going to do both of these. Okay, so let's start with this one. Our h is common here, so we can factor out h. That means we are going to be left with the g squared minus 1, which is equivalent to negative 4 negative 5 g squared. Okay, so divide here by g squared minus 1, divide here by g squared minus 1. So definitely this can cancel, and your h becomes the subject of the formula. So therefore, your h in this case is going to be the subject of the formula, which is going to be negative 4 negative 5 g squared everything over g squared minus 1. So it's like it depends with how you want your answer to look like, guys. Okay, it actually depends with how you answer want it to be like. So you say this is a 5 here. So if you wanted it to be like this, it's fine. If you wanted to work it from this side, therefore, what were you going to do? You're going to factor out the h here on this side. So this part was going to remain as it is, which is 5g squared plus 4 here. Then you can factor out h. We are going to be left with 1 minus g squared, just like that. So to find h, divide by 1 minus g squared, divide by 1 minus g squared there. So this can cancel. So your h is going to be 5 g squared plus 4 everything over 1 minus g squared. This is actually one and the same thing with the answer that we have got here. So it's actually one and the same answer. The way that it presented is look different, but it's one answer. If you want to see it's one answer, just pick any value of g that you want. You can pick to say, let g be equal to 1. Okay, so if you substitute 1 here in place of g, if you substitute 1 in place of g here, if you substitute 1 in place of g, 1 in place of g, you are going to have the same value of h. That is to show that these two are the same. Okay, so that is the idea there. So I just want you guys to revise as much as you can. So as you can see, it was a matter of expansion from the square root, expansion of fractions, here to remove fractions, expansion of brackets, collecting of like terms, and factorizing, then dividing by the bracket both sides, then you are done just like that. Okay, number 20, we are given, it is given that vector OA and vector OB are given as follows, then are position vectors relative to O, which is origin. Okay, express vector AB as a column vector, as we know that vector AB is going to be vector OB minus vector OA. So remember from a vectors, I explained this, that vectors, you work with what? The last vector, which is B, minus the first vector, which is A. So it's you can do this. You can find your AB here by simply substituting. It was a matter of substitution, guys, as you can see, because already they wrote OB for you as 4,1. So you can substitute, which is your 4,1 here, minus OA, which is, this is your OA, which is negative 2, 3. So that's what we had in this case. So as you can see, we can collect like terms, it's a minus and the minus here, which is a plus. So it's going to be 4 plus 2. Here is 1 minus 3, and this is just direct plus and minus is a minus. So if we add, we are going to have 6, 1 minus 3, which is a negative 2 in this case. So it's going to be 6 minus 2. So that's what you're going to have as your vector AB. So it depends with the question that you'll be given actually, and how are you supposed to answer that question. And that's it. And this question, guys, it was one of the most important questions, because actually we talked about this question, but it was another, like we are just doing it from the basic, like we are just having general values. But this time, they gave us like a statement that you're supposed to work from it to find P. If it is given that BP is equal to OA plus 2B, 2OB. So let's start by this BP first, because there must be something that must come out from this BP. So let's state, find this BP, which is, we are given that it's OA plus 2OB. So OA, we have got our OA here. Take note, our OA is there. It's minus 3, minus 2, 3. So we are going to have OA, which is minus 2, 3. So this is your vector OA here. Okay, then plus 2OB. So it's going to be plus 2 times the vector OB. Okay, your OB is there. Your OB is what? 4,1. That is going to be 4,1 here. So you've got 4,1 like this. All right. So that's what you're going to have. Expand your brackets first. I'm going to explain what exactly is going to happen there. Let us just find our answer first. So it's going to be minus 2, 3 here, plus 2 times 4. Remember, 2 is a scalar, so it multiplies everything, which is 8. 2 times 1, which is 2, like this. Okay, so we can add these 2 and see what you're going to have. So if we add these 2, we are going to obtain something like minus 6 plus 6, because it's minus 2 plus 8, so it's going to be positive 6. 3 plus 2, which is going to give us a positive 5. All right, so in actual sense, I want you to see what the question was supposed to be. It was supposed to say, given that BP is equal to, because that is what you're given. This is your BP, which is this expression. And we got it that it's what? It's 6, 5. So they were supposed to give you a question like this. And they know that if they just give you this BP like this, and they ask you to calculate the code, you can get the answer. Why? And remember, I told you guys, when you are given a vector, you can formulate a vector from where it was written, like from its origin. where did we actually obtain this vector BP? We know that our BP was supposed to be obtained from this equation, just like the one that we used here for AB. Remember what we did on AB? We said AB is OB, which is this B minus A. So it is the same thing that you're going to ask yourself to say, our BP here was supposed to be from this equation. BP was supposed to be equal to OP minus OB. This is what we're supposed to get, whereby P minus B. And if we are to obtain OP as a vector, it means we have got the coordinates of P, just like here on this one. This OA here is a vector, but it means we are given point A here, which is minus 2, 3. This part I explained about it. So it's minus 2, 3 that you're given. It's the same thing here. It's vector B. Yes, it's vector B, but the point that is there is 4, 1. That is what it means. So what I'm trying to say is that if you are to find this vector P here, it means you also have the coordinates of what? Of the point P. But where are we going to have this? Which means we have to make proper substitution now. In place of what? In place of our BP, let's substitute what we have, because we have got this vector BP here, which is 6, 5. That is our vector BP, which is equal to, we do not have vector OP, so we're just going to write it as vector OP minus vector OB. Now, our OB is that point that you are given. Already you are given it as a vector here, which is 4, 1. So you're going to substitute your 4, 1 there. So this is going to be 4, 1 like this. Okay, so this is your vector OB. Now let's find OP. We can transpose this to the left-hand side. It's going to be a positive because it was a minus before. So it's going to be 6, 5. Whatever that we are going to have, we add this vector that we have, which is now 4, 1. And this is going to give us vector OP. All right, so let's add, guys, and see what you're going to have here at the end. So if I am to add this properly, I'm going to obtain 6 plus 4, which is a 10. Okay, we add this to 6 plus 4 there, that is 10. 5 plus 1 here, which is 6. So that is your vector OP, like this. All right, so if this is our vector OP, what about the point P? We are now going back to this idea that I was explaining here, that you are given OA, but you've got point A. You are given OB, but you've got point B. So it means here we are given vector OP in this case. This is what we are given, which is our vector OP here. So it means we are given also P as a point, which is 10 as to 6 like this. So this will be your point P. So take note, guys, do not write the vector, write a point. This is a point, not a vector. That was the case. And let's just see another part of the question. I think this part was actually clear like that, just like that. Okay, on number 21, it's a Cartesian plane that you're given. Know your graphs, guys, your straight line graphs and so forth. So this is a straight line graph, and we are given that the diagram shows a straight line 3x plus 4y is equal to 12. So this straight line that we are seeing is of the equation 3x plus 4y, which is equivalent to 12. That is the equation of the line that you are given in this case. And where it cuts the x-axis, take note, it cuts the x-axis at P, which means this point at P is your x-intercept. Whenever it cuts the x-axis, that's your x-intercept in this case, and it cuts the y-axis at Q, which means at Q here, that's our y-intercept. Okay, at Q here, that's your y-intercept. All right, so this is your y-intercept there. So the question is, state the, I say, guys, it's not calculate, it's actually state, which means by sight, by just looking at this, you can obtain your answer. It's not calculate, it's to state, which means you can just have the coordinates at P. Why? Because they know that if you are given P, which is a point which is on the x-axis like this, is the x-intercept, where we said in the x-axis, y is equal to what? Y is equal to 0. Always in the x-axis. So which means at this point, you know that at this point, y will be equal to 0. So you can substitute into this equation 3x plus 4 times y, which is a 0 here, must give us a 12. So by doing this, we are going to have 3x, which is equal to any number times 0, that's a 0 here, which is 12. So you can divide by 3, you can divide by 3. This is 3 both sides. So 3 and 3 can cancel, which means our x is going to be 3 into 12, which is 4. So it means at this point here, our x is 4, but we need the coordinates of P. So as a point, remember your point is made up of x and y here. So your x is 4 and your y is a 0. Okay, just like for Q is the same thing. You're just going to do the same thing. For Q is the y-intercept, where we know that in the y-axis, x is equal to what? X is equal to 0. So if x is equal to 0, which means we can take it as an advantage on your point here, on our point, we can take this as an advantage to say that if we know that x is equal to 0, therefore, what is the value of y here? Because we know that x is equal to 0. So you can simply substitute into your equation. This time, it's x, which is equal to 0 here. So what is the value of y? Which means you're going to be left with this part. 4y is equal to what? Is equal to 12 divided by 4, divide by 4 in this case. Okay, so your y is going to be 4 into 12, which is a 3. So this is going to be a 3 here. So this point here is actually a 3. So that's what you're going to have in this case. We've got 3, so it's going to be 0, 3, like that. All right. Then on number B, calculate the gradient. Okay, the gradient of the line. If you're asked to calculate the gradient, remember you must write your equation in the form of y is equal to mx plus c. Or you can use these points here. Since you have got these 2 points, you can calculate gradient from there. The point Q and the point P. You can use points since you know that gradient is changing y over changing x. Or you can just rewrite your equation in the form of what? Y is equal to mx plus c. That means here I'm just going to be left with 4y, which is equal to, if I transpose this 3x to the right-hand side, is going to be minus 3x, which is minus 3x plus 12. So you're going to have minus 3x plus 12. Divide by 4 because I have to make y to be the subject, so I have to divide by 4 each and every part of the equation. That means y is equal to minus 3 over 4x. So it's going to be minus 3 over 4x plus, in this case, it's 4 into this, which is going to give us a 3. All right, so we are not worried about the other part. We are worried with the part that has got what? We are worried with the part that has got x here, the m, this one that is multiplying x is your gradient. So this part that is multiplying your x here is your gradient. So that was your gradient. In this case was negative 3 over 4. All right, so that was our gradient there, which is negative 3 over 4. So easy like that, guys. You can simply obtain your values. Okay, so that's your gradient. And the other part is to calculate the length of line PQ, the length of line PQ, this one. So to find length, length is actually from this formula. Length, it can be distance. They can ask this as length, or they can ask this as what? As distance. So you use the distance formula, which states that the length or the distance is equivalent to x2 minus x1 squared, okay, plus y2 minus y1 squared. So this is the formula for length. You can use this formula for length. What am I trying to say is you'll be given points, isn't it, A and B, because you are talking of P and Q. So P, you have got the point P here that we calculated. We said P is 4, 0 here. So you are going to write these points. This is your P, which is 4, 0 here. And we've got our Q was 0, 3. This is your Q here, which is 0, 3. So your Q at this point was 0, 3. So this was actually 0, 3. So what I want you to see is that this is 4, 0 here. So what I want you to see is that you're going to name these points. So you can just name these points because we want x1 and those. So this is your x1, this is your y1, This is your x2, this is your y2 from the first point, second point. Okay, so you can use this formula now, or you can use this information to calculate the length, since we are given that. All right, so let's just put it in another way like this. All right. So that's what you're going to have in this case. So your x2, in this case, this is your x2 here, which is 0. So it's going to be 0 minus x1, which is 4. So it's going to be 0 minus 4 squared plus y2. This is your y2 here, which is 3 minus y1. This is your y1 here, which is a 0 like that. Okay, so then you square. As you can see, it's y1, y2 minus y1 squared. Okay, so performing this calculation, we are going to end up with something like 0 minus 4. That's minus 4. So this one is going to give us negative 4 squared plus 0. This one is 3 minus 0, which is 3. So it's going to be 3 squared. And if you are to simplify further, you're going to obtain the square root of minus 4 squared is simply minus 4 times minus 4, which is a positive 16, plus 3 squared is 3 times 3, which is 9. So if we add this, is 9 plus 16, which is going to give us 25, and the square root of 25, which is 5. So which means our length in this case is going to be 5 units. Remember, length is just measured in units and like that. Okay, so that's how you calculate length. And I got another question from one of you guys saying, how do you calculate the midpoint? If there's a question, if it might ask you like that to calculate the midpoint of PQ, okay, the midpoint of a line. So the midpoint, you use this concept, you take those points, but this time you add the values of x together, x1, x2, together, you divide by 2, okay? You do the same for y, it's going to be y1 plus y2 like this, you divide by 2. That's a midpoint. So in this case, if the question needed us to calculate the midpoint of PQ, it means we are going to take, this is our P here, and this is our Q. So we're going to add x1, which is 4. So we're going to write it like this, 4 plus x2, which is a 0 here, over 2, okay? Into y1 plus y2, our y1 is a 0 there, so it's going to be 0 plus 3 over 2. That's how you calculate the midpoint. So 4 plus 0, that's 4 divided by 2, which is going to give us 2. 0 plus 3, that is 3. 3 divided by 2, that is 3 over 2 like this. So this is if the question needed you to calculate the midpoint. I'm just saying if, because this is a question that someone asked me, and I was just replied on the comment section there, but at least maybe you can actually see the exact thing, how it's supposed to be done, so that you understand. Even if another question is going to ask you about this, you can actually be able to attempt that question. Okay, so that was it, guys. Let us move on to question number 22, where we are given information under statistics. So don't mind about this table, which is not clearly shown. But that's what we had. We have got the height, h centimeters, and these are the height 20 to 30, 30 to 40, 40 to 50, and 50 to 60. This is 60, 60 to 70 here. Okay, and these are the numbers that you are given, which is 4, 6, this is 10, this is 2, and this was 8. Okay, so these are the numbers that we are given there. The table shows the heights of 30 learners. Okay, so these are 30 learners. That's so 4 plus, that's 10, 20, 30. Okay, so that's 30 there. Okay, so the first question is to state the modal class height. So remember, the modal class is the class that has got highest frequency. Our highest frequency is here, but what is that modal class that has got that highest frequency? So you state the class now. So the class that we have got there is 40. You write as it is, so it's 40 is less than h is less than or equal to 50. So that's your model class, this one. You write the class as it is. You do not write the frequency, no, you write the class. All right, so that is the case. Okay, let's move on to another part. estimate the mean height of the plants. Okay, so the mean height, we know that mean height, guys, I told you that you have to work with the class centers in order for you to have this mean. You calculate the class center for the first class, you multiply to the corresponding frequency, and so on. You move on to the second class, you calculate the class center, you multiply by the frequency, everything over the total frequency. I think I told about this, guys. So let's get back here and see our class center. Remember, your class center, you add the upper class to the lower class, then you divide by 2. So it's upper class plus lower class divided by 2. When I'm saying upper class and lower class, you just add these values here. So this is 20 here and 30 here. So if we add 20 plus 30 and divide by 2, that's our class center. So you do the same. So 30 plus 20 divided by 2 is going to be 50 divided by 2, which is 25. So that would be your class center there, which is 25. So it's 25 times the frequency. All right, so remember I said it's class center times what? Times frequency in this case. So it's going to be 25 here times the frequency, okay? Which is the frequency which corresponds with this class. And if you have to cross-check in this class, these are the number of plants here, which is your frequency. So the frequency here is 4. So it is going to be times 4. All right, so this is times 4 here. We are done. Plus, we move on to the second class. We have got between, in this class, we are working with what? 30 and 40 here. So if we add 30 plus 40, that is 70. 70 divided by 2, which is going to give you something like 35. So this is 35, which is your class center, times the frequency. What is our frequency? It was 6. Yeah, that was 6 here. The frequency is 6. So you're going to multiply to 6 here. You move on until the last class. So that's what you're going to do. So let's move on to the other class here, which is 40 and what? 40 and 50. So if I add 40 and 50, that is 90. 90 divided by 2 is 45. So it will be 45 times frequency, which is 10. So it's going to be 45 times 10 there, which is our frequency. Okay. Then let's move on to the other class, which is 50 to 60. So we have to add this to 50 plus 60, which is 110, divided by 2, which is something like 55. So you're going to have 55 here. So this is 55 times the frequency. We saw that the frequency there was 2. That was a 2 there between this class. So you have to take the frequency here, which is a 2. Okay, then you move on to 70, 60 and 70. Here you add 60 plus 70. That is something like 130. So if you divide by 2, that would be 65. That is your class center. So remember, you add the 2, then you divide by 2. So it's 65 times the frequency. And the last class here, at a frequency of what? This is the frequency of 8 here. So you're going to multiply by 8, which is your frequency. All right, but what I'm saying, you have to divide by the total frequency. Okay, so you have to divide everything here by the total frequency. So you're supposed to add all these numbers, but lucky enough, they gave us this information that the table shows heights of what? Of 30 plants. So that is your frequency there, which is 30. So you're going to just divide this by 30 here. All right, so let's just perform our multiplication as usual. That means we are going to have something of this nature. If you have to multiply properly, that's 25 times 4. Here it's going to give us something like 100, if I'm not mistaken here. 35 times 6, which is 210. So you have to multiply each and every part. 45 times 10, that one is 450. 450 here. All right, so it's going to be 450 on this part. And we move on to 55 times 2, which is 110. 55 times, yeah, that's 110 there. All right, plus 65 times 8, that's going to be 40, therefore, then 8 times 6, which is 48, plus 4, which is 52, so it's going to be 520. All right, so you just add everything, then you divide that whatever that you have got here, divide by 30. All right, so if we add everything on top there, which is on the numerator, we are going to obtain something 1,390. So add properly, guys. This is what you're going to obtain. Divide by 30, so it's gonna be 139 over 3, of which I can just divide here. That's 3 into 13, that's gonna be 4. Remainder 1 into 18. Into 18, that is 4. That is in this 19, we're going to have 18 into, that is 8. In this case, if not, it's gonna be 6, not 8, 48. So it's gonna be 6 here. All right, so this will be a 6 here into 18, isn't it? Yeah, that's a 6 there. I'm working with 3, so it's gonna be a 6. So there's gonna be a remainder of what? Of 1. So it's going to be 1 over 3. All right, so that's what you're going to have. Or it was going to be, was 1 over 3, guys, is comma 3, isn't it? Comma 3, something like that. Okay, so you just have to write the exact thing. I don't know which one was best for you, but that was your mean. Then on B, a plant is chosen at random. We are now back to your probability there. Find the probability that its height is more than 40, but less than or equal to 60. Take note, it's more than 40. More than 40, that is what we have here on our, if you have to cross-check here, on our table here, that's what you're going to have. We are given that it's more than 40, but less than or equal to 60. So more than 40 years, you can check here, H is greater than 40, so H is more than 40, which means you're starting from this class. Less than or equal to 60 is here, H is less than or equal to 60, which is at this point. So which means your answer is going to be within this region, between these two, greater than 40, but less than or equal to 60. So which means you've got this 10 and this 12 and this 2. So you combine 10 plus 2, which is 12. So those are the elements, or those are the, say that we're within that range, which is 12. So that's your probability. You just picked ones, so it's just going to be just that number of plants which are there, which is 12 over the total. How many seeds do we have, or how many plants? We have got 30 plants in this case, so we're going to divide by 30. So that was it, guys, and you can reduce this by 6. 6 into 12, that is 2. 6 into 30, which is 5. So it's going to be 2 over 5, just like that. All right. So those are the typical questions, and how you're supposed to answer them is very, very important, something like that. Okay, then you are given on number 23, it's actually a triangle. And this is 2,1, something like that. This is 2,1 here. That's 2,1. All right, 2,1 there. So this is actually 2,1, and this is 3,5. Here is 3,5, and this is 4,2. Okay, then the points that we are given, the points that we have got, triangle ABC, the points respectively, and the size, which are the ones that we are given. And the last part is the one that I want us to cross, which is the important part. BAC is equal to BED. This angle here that we are given and this angle here, they are equal. So the first question now is to name the triangle which is similar to triangle ABC. Okay, remember, guys, I told you whenever you're dealing with similar figures, you work with angles which are the same. So the triangle ABC is going to be similar to which triangle? The triangle that you have to get, or that you have to take, is supposed to be of equal angles from A to B to C. So let's locate the angles which are the same from our diagram. Okay, already we are given here, these two, they are equal. Angle A and angle E, they are the same. Okay, the other thing that I want you to see is that this angle B is the same for all the triangles. The bigger triangle and the smaller triangle, they are all joined at what? At B. So this is a common angle for all the triangles, which is your angle B. It's a common angle, this one. Okay, that's your common angle. Okay, so you've got a common angle here. And the other thing that you're supposed to note is that definitely this is a triangle. If these two angles are the same, definitely it means this angle at D is going to be the same as this one at what? At C. There's no way, guys, like you cannot say I've got a triangle like this. Okay, let me just show you what I'm trying to say. If this is 30 degrees here, and this is 70 degrees here, all right, and this is 70 degrees here, and this is 30 degrees here. By default, whether these triangles are the same or not, if these two are the same, 30, 70, 37, it means this remaining angle here is also the same. There's no way, because you know that angles in a triangle, they add up to 180. So the remaining angles will be the same. So that's what we had. So it means the angle here at D is the same as the angle at what? At C. So now let's name our triangle. We said A, B, C. To name similar figures, you name them according to equal angles. Angle A is equal to each angle, according to our diagram. This is your angle A, which is equal to angle E. So that's how you take your similar figure. So this is going to be angle E here. So it's going to be triangle E. You move on to angle B. All right, so let's cross-check our B. B, we said, is the common angle for both triangles. So which means this triangle is going to remain with B. It's a common angle, which is B. Then let's move on to C. Our angle C here, this is our angle C, this one, which we said C will be the remaining angle, which is the same as this angle at D. So that's what you're going to have. So angle C and angle D are the same. So that's how you take similar figures. They are equiangular. You take them from equal angles. So those are the two triangles which are similar. And calculate A, B. So definitely, if you are working with similar figures, try by all means to go back to those similar figures. Formulate an equation, because I told you guys that from ratio of sides, it is the same. So you're going to use ratio of sides, which is AB. So you're going to take ratio of sides here, AB, over the corresponding side, which is EB. So it's going to be EB, which is equal to, we move on to this part. So it's just a matter of taking what? Taking the sides which are the same. So you said AB over EB, then we have got this one, B to C. So it's going to be BC over the corresponding, which is a BD. So we've got a BD here, which is equal to, we move on to A and C, which is our last one. So it's A to C, and this one is going to be E to D. So it's going to be E to D like that. Okay, so as you can see, everything is there. What we just need is to substitute so that we can be able to find our AB. So definitely this ratio is supposed to be part of our answer. Why? It contains B. So we're going to use this AB. So it's going to be AB over the corresponding side, which is EB. So we have to just take on our diagram here, which is EB from E here to point B is going to be 4,2. So that's one. That one is 4,2. So this is going to be 4,2, which is equal to, you now take where there are complete values in this case. So you have to cross-check, are there complete values on the ratio that I'm taking? If there are no complete values, then leave it like that. BC over BD, let's cross-check. This is BC. From BC to BD, we do not have complete value. So this ratio, let's leave it. Let's move on to this one, AC over ED. So AC here, this is your AC from A to C. We take the line from A to C, which is 3,5. So that one is going to be 3,5. Okay, so that's what you're going to have from this part. So it's 3,5, which is AC. So your AC is 3,5 over ED, which is your ED in this case from E to D, that is 2,1. So this is 2,1 like that. Okay, so that's what you're going to have, and you're just left to find AB. So remember, guys, you can do this type of multiplication to remove this because it's in the denominator here. So how do I do it? Dividing. So I'm going to multiply. So multiply by 4,2, multiply by 4,2. I can just get rid of this 4,2 here. So AB is going to be, okay, so this is what I'm having at the end. So I can just divide, maybe, let's just divide 3,5 over 2,1. So just multiplying by 10 here is going to be 35 over multiply by 10, which is 21, because as you can see, I've got one decimal place throughout, one decimal place is 35. Reduce this by 7, it's going to be 3. By 7 here, it's going to be 5. Okay, so these two here, they are going to give us 5 over 3. So it's going to be 5 over 3 times 4,2. So this is what you're going to have, and you can divide using your idea of decimals there, which is 3 here. 3 into 4, that is 1. Remainder 1, so it's going to be a comma. Then 3 into 12, which is 4, so you can multiply the remaining part, which is in this case, if we are to multiply this, that means we are going to be actually left with what? With AB in this case. So if you have to cross-check, your AB is going to be equal to 5 times 4 here, that is a 20. Okay, we've got 2 here, 5 times 1 here, which is a 5 plus 1, which is 7. And how many decimal places? We just have one decimal place, so it's going to be 7,0 here, which is equal to 7. So that is your AB. So in this case, our AB is going to be 7. That's what we have. And these were centimeters actually. So it's going to be 7 centimeters. So that's how you play around similarity, guys. That's how you play around similarity, just like that. Okay. Then on the other item, we are given that the area of triangle ABC, calculate the area of triangle ABC, given that the area of triangle BDE is 22,5. So this is 22,5 square centimeters, which is area of triangle what? BDE. Okay, so let's cross-check where we've got our BDE on our diagram here. BDE, this is our BDE here. Okay, so we are given area of this triangle, which is BDE. This is the area that we are given, which is 22,5 square centimeters. Okay, and all we need is to find the area now of the bigger triangle, which is ABC, which is the bigger triangle ABC. But let's see, guys. Before, if you are to cross-check, we say these two triangles, they are similar. So we can work out from ratio of what? Of the similar side, because we have got ratio of sides. If you are to cross-check, guys, when we have got complete ratio here, we divided this ratio here of 3,5 over 2,1. This is the complete ratio that we are given, 3,5 over 2,1, which I divided here and obtained 5 over 3. We ended up with 5 over 3. So this ratio of 5 over 3 that we are given, remember a fraction, guys, ratio can be given as a fraction, or it can be given like this, 5 as to 3 like this. It's still one in the same format or one in the same ways. But this is your ratio of sides, this one. It's a ratio of sides. This one is ratio of sides. So if it is ratio of sides, it means that is your scale factor. It cannot be used whenever you're calculating area. So here we need area of triangle ABC, which means we have to find the ratio of what areas from this part that we have got here. So 5 over 3, that is our scale factor. So which means we are going to square this to obtain our area factor. 5 squared, which is 25, over 3 squared, which is 9. So this one is your area factor, which is the ratio which is going to be used for area, whereby this 5 here was obtained. I want us to cross-check, where did you obtain this 5? It was from this 3,5, and our 3,5 was from what? This triangle, the bigger triangle here. We said on this part here, triangle, let me indicate this here. All right, we said this triangle ABC is similar to this triangle. So which means the 5 is from the bigger triangle, the 3 is from the smaller triangle. So it also applies even on your area. If the 5 was from the bigger triangle, which is your ABC, it means this 3 here is from the smaller triangle, which is this one, your BDE. That is what it means. So now you are given ratio of area, so which means you can play around with this ratio of area to say that 25 is representing the area in triangle ABC, which is the one that I need to calculate here. So 25, according to ratio of areas, is representing the area of triangle ABC, which we do not know in this case because we do not know this area. So we are saying this is going to be equal to what? We do not know this. Okay, so let's just remove this part. All right. So we do not know this answer for 25, but what we know is that this 9 here, which is from our BDE, which is the smaller triangle, it has got the area which corresponds, and that area is 22,5. So this is going to be 22,5 square centimeters. This is the area that you are given. So what is the area now of our triangle ABC, which is the bigger triangle? So it's now a matter of your simple proportion. And so this is how you work out your similarity, guys. So this one is going to be more. All right, so that means in this case, if this is more, then let's take our ratio. So it's going to be 25/9 times 22,5. So this is what you're going to have, something of this nature. So you can reduce 9 into this. That's going to be 9 into 22, which is, you have to just revise 2. It'll be into 18. And what we have there, which is a remainder of 4. Yeah, that's going to be a remainder of 4, and into 45, which is 5. So you're going to be left with 2,5 and 25. So here, just multiply as usual, 25 times 25, which we know that is 625. But how many decimal places do we have? We've got 1 decimal place, so it's going to be 62,5. So this will be 62,5 square centimeters. So that was the area of the bigger triangle. Okay, sometimes they might not ask you this. They might ask you to find the area of this triangle, this quadrilateral here, this one. If the question was asking you to calculate the area of this quadrilateral, which is the area of what? Which is the area of this, let me change, which is the area of A, let me write it here, the area of this quadrilateral, which is AEDEC, AEDEC. We do not know even the name of this quadrilateral. What is that? Is that a trapezium or